All right, in this video, we're just going to look back over the basics of trigonometry and get used to solving right angle triangles again. So when we're looking at right angle triangles, there are a few different methods of solving that we can use. So first of all, we have the Pythagoras theorem, a squared plus b squared equals c squared. And what's important about this is that A and B are the two shorter sides of the triangle. C is always the longest side of the right angle triangle and is always directly across from the 90-degree angle. We also know that if we have one of the angles here, that the sine of A is the opposite over the hypotenuse. The cos of the angle A is the adjacent over the hypotenuse, and the tan of the angle A is the opposite over the adjacent. So all of this information is relevant in terms of solving a problem involving a right angle triangle. Now, for the purposes of this video, we're going to look at questions from exercise 4 on pages 174 and 175, just to give you an idea of how to apply this knowledge to these kind of questions. So the first question we're going to look at solving is question number 6 on page 175. So we have a woman swims across a river from P to Q at 41 degrees to the bank PR, a distance of 25 meters. So we have P, Q, and R. This is 25 meters here. This angle here is 41 degrees. This angle here is 56 degrees. And we know that the distance that she swims from P to Q is 25 meters. So this woman starts swimming from P to Q at an angle of 41 degrees, and she returns along the line Q to R. So there's 3 things that we're being asked to find. We're being asked to find, first of all, the width of the river, so W, given that this here is a right angle. We are being asked to find the distance from P to Q and the distance from P to R. All right, first thing we need to do is determine the width of the river. All right, now we have 2 possible right angle triangles that we can work with here. If we look at what we need to do is look at which one we have the most information about. Now, because this is a parallel bank, we know that this angle of 56 degrees also applies here to this angle of 56 degrees. So we're looking at alternate angles there. Now, unfortunately, that doesn't really help us an awful lot because we don't have any of the sides of the right angle triangle, so therefore it's of no use to us. We also have a right angle triangle over here that also involves the width of the river. We have 41 degrees here, which means using alternate angles, we have 41 degrees down here. And we also have the distance from P to Q is 25 meters. So if we take that out separately, we're looking at 25 meters here, the width of the river, and 41 degrees. Using the 3 ratios that I just spoke about a few minutes ago, sine, cos, and tan, we can work out what the missing side is. So the first thing we need to do is identify which ratio we're dealing with. We're dealing with the opposite and the hypotenuse, which means that we're looking at the sine. So the sine of the angle is the opposite over the hypotenuse, meaning that the sine of 41 is equal to W over 25. All that's left to do now is isolate the W by multiplying across by 25. So we have W is equal to 25 sine 41, which we then type into our calculator, making sure that we are on degree mode. By the way, if you're on radians mode, you'll get the incorrect answer. So just change your calculator to degree mode. 25 sine 41 gives us an answer of, and we want to correct to 1 decimal place. So that's the width of the river is 16.4 meters. So that's the first part of the question done. So we have the width of the river. So I'm going to put that into my diagram now, the fact that we have 16.4 here and 16.4 here. It's always good to update diagrams as we go. The next distance we're looking for is, sorry, that should be RQ there, not PQ, R to Q. So we're looking for this distance. Now, there's no good in looking at this triangle here. We have to focus on this triangle. So again, we're going to draw the triangle out separately and look at what information we have that we could apply. So we have 16.4 meters, we have 56 degrees, and we're looking for the hypotenuse this time. This time we have opposite hypotenuse, so again we're looking at the sine of the angle, so sine of 56 is 16.4 over, let's call it x. Again, we're trying to isolate the x. This time, what we can do here is we can swap the position of the x and the sine 56 because we have to multiply both sides by x and then divide both sides by sine 56 to isolate it. So therefore, we're looking at x is equal to 16.4 over the sine of 56 degrees. Again, typing that straight into our calculator, 16.4 over sine 56. Again, making sure we're on degree mode, gives us 19 point, is it correct, one decimal place, it's so 19.78, so 19.8 meters. Always make sure you put in your units for a trigonometry question as well. All right, so that's the second part of the question done. Last thing we're looking for is the distance from P to R. Now, if we look at what we have here, we have a non-right angle triangle because 41 and 56 degrees gives us a total of 97, which means that the remaining angle in the triangle is only 83. So we can't work with this triangle just yet because we are not dealing with non-right angle triangles yet. So we have to figure out another way of figuring out this total distance here. Remembering that the two banks are parallel, the distance from P to Q plus the distance from Q to R will be the same as the distance from P to R. So, sorry, not from P to Q directly. So from this point parallel to P to the point Q, so let's call that P1 and R1. If we can find this distance here across the bottom, because we have two right angle triangles that we are dealing with, then we can find the distance from P to R. So we have, that was 19.8, sorry, I should have put that in. So we have two of the sides of this right angle triangle. Now we can either, we have a choice here, we can use the 41 degrees and get the cos or the tan of 41 degrees to find the missing side, or we can use the Pythagoras theorem. Either or is going to give us the sufficiently correct answer here. So if we're looking at the Pythagoras theorem, for example, we know that this is 16.4, this is 25. Let's call that side B. We know that a squared plus b squared equals c squared. Now at leaving cert level, we would expect that we can rearrange this straight away to b is equal to the square root of c squared minus a squared. That's just subtracting the a squared from this side and then getting the square root of your answer. So filling in our information, we're looking at 25 squared minus 16.4 squared, and that gives us an answer of, and is it correct to one decimal place? Correct to the nearest meter, so we'll say 18.9 meters for this one. You repeat the process with this triangle here, so the distance from Q to R is going to be the square root of 19.8 squared minus 16.4 squared, which gives us 11.1, and together then the distance from P to R is 18.9 plus 11.1, which gives us 30 meters, correct to the nearest meter. So that's how we use our basic knowledge in terms of breaking down a problem and applying the sine, cos and tan and Pythagoras theorem. So using this video and using that basic knowledge, I'm going to give you a few questions in Google Classroom that I want you to attempt and get yourselves up to speed for moving on for tomorrow. All right, thank you.